Hey, everybody, welcome to today's lesson. We are going over experimental and theoretical probability. And today we're going to take that knowledge of experimental and theoretical probability and move it into and extend it into making predictions based off theoretical probability and experimental probability. For example, let's say Cedric's flipping a coin and he's keeping track of the results and he puts it in this chart. Well, it says, what is the theoretical probability for both heads and tails? So, well, the theoretical probability for heads is 1/2. Theoretical, what should happen, should. All right. And the theoretical probability for tails is 1/2. Now here, down here on number 2, it says, what is the experimental probability for each? Well, the denominator for experimental is based on how many trials were actually performed. Because we're talking about experimental, we're going to use this data in this chart, and it's going to be the probability based off this experiment or the data that we've actually taken. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 heads, and 1, 2, 3, 4, 5, 6. And then we end up having 6 tails. So altogether that is 15. And so the experimental probability now is not for heads 9/15, and the experimental probability for tails is 6/15. And we could reduce that if we were to reduce it by 3. Now it says, based on the theoretical probability, we flip the coin. If we flip the coin 20 times, how many times should we expect to flip heads? Well, we know that the theoretical probability of flipping heads is 1/2. And so that means 1 out of every 2 times that we flip the coin should be a heads. And if we extend that 20 times, we're extending that 10 times, expanding it 10 times, then we should also expect flip a heads out of 20 times, 10 times, half the time. And if you notice, if I were to divide each of these by 10, I will get 1/2, okay? And so it's the same fraction, it's just been expanded for the amount of times that I'm actually planning on doing it. Okay. Now this says, based on the experimental probability, if we flip a coin 20 times, how many times should we expect to flip the heads? Well, what's the experimental probability? The experimental probability of heads is, it's as we said, was 9/15. Okay. And we want to know out of 20. Okay. So what we could do here is we could figure out what multiple do I need to get from here to here, and we could do that by dividing. That's one. This is one option. And so this is going to be 0, 1, and it leaves over 5. And then so that would be 3. So this would be 1.3 repeating. And so over here it should be 1.3, because this is times 1.3. 15 times 1.3 will give me 20. So I'm expanding it 1.3 times. So I could take 9 times 1.3 and get what I need to get. 9, 18, 27, 9, 10, 11, 11.7, or 12 for short. 12, or 12 if we round it. Okay. Another way I could do this is I could.
Please dismiss all 404. Please dismiss all 404.
Sorry about that. Another way I could do this is I could, let me erase this real quick. Another way I could do this is I I could say I could divide this and get, I could divide this by 3, and I get 369. That's 3, 369, 12, 15, 3/5. So I can get, so if I subtract, if I reduce this, I'll get 3/5, and now that goes easily into 20. And so that's times 4. And so this would be times 4, and that would be 12. That's another way to do it. I reduce this fraction here, and then I can expand it. Okay, so those are a couple separate ways to do it. Here's another way to do it. Let me see. Draw. Let me erase some of this. So all we're doing is we're using this proportionality piece that we've been using for the longest time now. And we're using it in a different context. So I could take 9/15 and 20, and I could multiply not 20 times 9 and divide it by 15, cross multiply and divide. So that would be 180 divided by 15, which would be, it doesn't go into 1, but it does go into 18 one time, and it leaves over 3, and then it goes into 30 2 times, so that'd be 12. And so cross multiply and then divide. So those are 3 separate ways that you could solve proportions. All right, now let's go into this. Now we have a spinner, and then they spun this spinner, I don't know how many times, but let's read it. So we got a spinner, it's got 8 sections on here. We got 3 1s, 3 2s, and 2 3s. So if we're talking about theoretical probability, the theoretical probability of spinning a 1 is really 1, 2, 3. It's 3 out of 8. Spinning a 2, 1, 2, 3, is 3 out of 8. And spinning a 3 is 2 out of 8. Okay. And here we have some data here. This is our experimental probability. They're experimental. And we have 10 here, 10 here, and 4 here. Altogether, that gives me 24. Okay. So there's 24 trials. There's 24 trials. All right. And so this theoretical probability is 10 24ths, 4 24ths, and 10 24ths. That's the experimental probability. Experimental probability. All right. It says predict the number of times the spinner will land on 3 if spun 40 times. Okay. And since it doesn't specifically say experimental, I'm going to use my theoretical. And so 3 out of 8. And if it's spun 40 times, that's times 5. And so I should expect it to land on there 15 times. Okay. Using experimental data, how many? So this actually says experimental data. How many times should we expect to spin a 3 when spun 240 times? Well, the experimental probability of rolling a 3 is 10 24ths, 10 24ths. And if we spin that 240 times, that's times 10. Times 10, that is 100 times we should expect to for it to spin on 10. Okay, and so I hope this video helped and that you understand a little bit about how to make predictions using theoretical and experimental probabilities.